So today we're going to be taking a look at the surface area of a pyramid. So first let's start with the question, what is surface area? Surface area is the measure of the exposed surfaces of a solid in terms of square units. So let's take an example of this pyramid right here. So first off, I just want to rename these lines L and W so it fits my little description up here. So we can find the measure of the surface area of a pyramid by multiplying the length times the slant height plus the width times the slant height plus the length times the width. So let me just illustrate this for a second. I'm going to first redraw this triangle right here with a base L to explain what slant height is. So slant height is basically the measure from the base of a pyramid to its vertex. Now, if you think of it in terms of the triangle that the slant height lies on, it's just the height of the triangle. So it's nothing new, it's just a fancy way of saying height. So here's our slant height. And we'll name this line S. So our slant height is S, and here's L. Now, what we can do to find the surface area of this pyramid is we can multiply. We can first find the area of this triangle right here. And we can do that by multiplying the length times the slant height over 2. And adding that to the width times its own little slant height. We'll notate that in a capital S. Width times its own little slant height over 2. But we're going to have to do that twice, right? Because there are 4 triangles, and we know that in a pyramid, the opposite triangles are congruent. So there are 2 triangles that will have this area, and 2 triangles that will have this area. So we need to multiply this by 2, and multiply this by 2. We can just cancel out these 2's. So we know that to get just this area, the area of all 4 of the triangles, ignore that little base on the bottom, you can do the length times the slant height times the width times the other triangle's slant height. Now if you want to get the total area, you can just add the width times the length to get the base. But for now, let's just focus on this area right here. What we get by multiplying the length times the slant height of one triangle plus, sorry, this should be an plus the width times the slant height of the second triangle. So we can use this formula right here to answer this question. Now the question says PRXYZ is a regular pyramid. The midpoints of its lateral edges are joined, there should be a J there, to form a square, ABCD. PR is equal to 10 and RX is equal to 12. So it tells us that PR right here is equal to 10 and RX right here is equal to 12. Now, if we want to find the lateral area of PRXYZ, we need to find the slant height. Well, we need to first find the slant height, but we'll go about finding the lateral area by adding the areas of all 4 of these triangles. Now, it tells us that PRXYZ is a regular pyramid. So what that means is it has a square base. Each of these little lines, the little lengths that form the base, are congruent. And it also means that the lateral edges, and examples of lateral edges in here are PR and PX, are also congruent in a regular polygon. So PR is congruent to PX, is congruent to PY, and so on. So to find the lateral area of PRXYZ, again, we just need to add these 4 triangles. Now, we know that the slant height right here is just the height of this one triangle. So let's redraw this one triangle so we don't have all this other confusing junk in the way. So let's redraw this triangle right here. Okay. So basically what we've done is we've redrawn one of the lateral faces, or one of the triangles. So here's P, R and R, and X and X. And right here, Rx we were given was 12. And we've also drawn our little altitude, which this altitude will also be a perpendicular bisector. So we know that this length, or half of this, would be 6, and it tells us that PR is 10. So now using the Pythagorean theorem, because this is a right triangle, we can find the slant height of this triangle. So we can do 6 squared, again this line is s, plus s squared is equal to 10 squared. Or let's square that out. 36 plus s squared is equal to 100. Then you can subtract 36 and you get s squared is equal to 64. So s is equal to plus or minus 8. But we know that it can't be negative 8 because it's the measure of a line, and the line can't have a negative length. So that's just plus 8, or 8. So we know now that s is 8, s is 8, and rx is 12. So now we have the height and the base of this triangle, so we can find the whole measure, the whole area of this triangle. So we can do 12 by 8 times 2 is 16, 1, and you get 96. But we need to divide by 2, and if you divide 96 by 2, you get 48. Now that's just the area of one of these triangles. In a regular pyramid, which we have here, a regular pyramid, you can, all of these triangles are congruent. So you can do 48 times 4, you get 192. And that will be the lateral area of PRXYZ, 192, because we didn't add in the base, just the triangles. Now it also wants you to find the lateral area of PABCD. So let's try this again also. So we know that AB is going to equal half of RX, because there's a geometry rule that says that when you connect the midpoints of two of the legs of the triangle, the length of this new line you've made is going to equal half of the base of the old triangle. So RX is 12. A and B are the midpoints of PR and PX, which are the legs of this triangle. So AB is half of RX, so AB is 6. And then we also know A is the midpoint of PR, and because PR is 10, half of 10 is 5. So now we can draw another little line for slant height down, and it will again be a perpendicular bisector. So because it's a perpendicular bisector, the measure of this line right here is just going to be 3. And then using the Pythagorean theorem, we can figure out that this slant height is 4. And now it just wants you to find the lateral area of PABCD, so we can ignore the rest down here. So you can do, we know the base, we know the height, we can find the area of one of the triangles. So let's do 6 by 4 is 24, that's the base times height, over 2 is equal to 12. And then, because there are 4 of these congruent triangles, because it's a regular polygon, again, ABCD, they tell us, is a square, so it has a square base. So it would be a regular polygon, so all 4 triangles would be congruent. So 12 times 4, you get 48, and that is the measure of the lateral area of PABCD, because we're not including the base. PABCD is equal to 48. Let's see if we can fit in C really quickly. What is the area of square ABCD? So we know that we said AB is equal to 6, and the area of a square is just the length squared. So the length is 6, so 6 squared is equal to 36. So the answer to this question is 36. And then similarly, what is the area of RXYZ? We know RX is 12, so that means that 12 by 12 is 144. What is the ratio of ABCD to the area of RXYZ? So that is 144. So that's basically asking us, what's 144 over 36? And that is 1/4, I believe, yeah. So the ratio is 1 to 4. Now, it's interesting because the ratio here of the lateral areas of both shapes is also 1 to 4. So that's just a little interesting fact. If you have half of the square, it'll turn into a quarter of the lateral area. And what is the area of the trapezoid ABXR? So we know that AB is 6, XR is 12, and the area for a trapezoid is half times the sum of the bases times the height. So half of the sum of the bases is 12 plus 6, which is 18 over 2, 9, and then the height is 8, so 9 times 8 is 72. And that is just on time. Alright guys, see you in the next video.